This is part 4, section 12.2. We want to find mean, median, mode, mid-range. This time we're given our information in this format. So again, I'm going to, just like we did up here, I'm going to put the frequencies above each value so I can see things a little bit more easily. So that's 1, 2, 4, 5, 2, and a 2. All right, so just like up here, we're going to add our frequencies to find our n value. So if you add those values up, you get that n equals 16. So there are 16 items in this set. Okay, now because this is a frequency representation here, we need to do the multiplications. So there's 1 times 10, it's 10, and then I'm going to be adding these together. So 2 times 11 is 22, 4 times 12 is 48, 5 times 13 is 65, 14 times 2 is 28, 15 times 2 is 30. You add those up and you get 203. So the mean of this data set will be 203 divided by 16, which is approximately 12.7. The median. So if our n value is 16, our median will be located at 17 over 2, which is 8.5. So I'm looking for the numbers between, I need to find the 8th and the 9th numbers here. So again, here I have one number listed. Then I add another 2 when I list these values. So I've got 3 total. And then I list another 4, and that gets me to 7 total. And then I list another 5, and that brings me up to 12, which means I've surpassed these 2. So when I listed 7 numbers, the last the value I had listed was 4. And then I started listing 5s, and that pushed me so that my 8th number was where I had right here is a 13. My 9th number was also a 13. So the median is 13. Okay. The mode. They made it easy for us to see that 13 appears the most. So the mode is 13. And the mid-range would be, I need to do 10 plus 15 divided by 2. And that ends up being 12.5. These are all fairly well clustered together, and it makes sense. Okay. So now let's do this with a stem and leaf plot, and this is not frequency distribution, and so we get to go back to the easier form of this where we don't have to do any multiplications. What I do want to do is I find it a lot easier to take it from this and list them. It's nice because it's easier to get them in order, because at least you know what your 10 value should start off with. So I have 28. And then I have 32, 34, 34, 39, 40, 41, 45, and 47. Yeah, it's really nice when these are written in numerical order over here because it makes it really easy to do this. But again, a stem and leaf plot doesn't technically have to be in order. Of course, the computer is going to ask you to do that. So how many values do I have here? Well, if you want to just know n, I mean, you could write it all out and you could count them, but really it's all right here. You count the number of ones values you have listed here, and that's going to be the number of entries you had. So n is 9, and I should have 9 values here. So now I add these up. So the sum of x, if I add up all of these values, I get 340. So the mean of this will be 340 divided by 9, which is 37.8. Now let's find the median. So that will be 9 plus 1, 10 over 2. So that would be the fifth number. 1, 2, 3, 4, 5. That's the median right there. The mode. It's also easier to see here when they're written in order like this. I can see that I have a 4 repeated with the same, that's hard to say, same stem, and I do have 34 repeated here. My mode is 34. And then the mid-range is my largest value plus my smallest value, and divide by 2. That gives me 75 over 2, which is 37.5. Okay. One last problem. Find the mean, median, mode, or say that there is no mode, and mid-range. And this chart gives us the net worth for the first 13 US presidents adjusted to millions of 2016 dollars. Okay. So I do need to put these in order, and I know I'm going to have 13 values. That part's nice. We don't have to count. So my n value is going to be 13. So my median is going to be at 14 over 2. So the 7th spot is going to be my median. So, I mean, I could start listing these, but since I've got a chart already, maybe I can list them and not get them messed up. Let's see. Okay. So the smallest one is 4. So that's the first one listed. And then the next one is, then there's 6. And then 7 would be third. And then 11, fourth. And now I'm going to jump to my cheat sheet here. This is 13th and 5th and 12th and 10th and so on. And I promise that you can double check that I have these in order, because believe me, I double check them 2 and 3 times. Okay, so this is the order. And so the 7th number was the median. So the 7th number is right here. Mr. Van Buren. The median is $29 million. Okay. So, mode. Do we have a mode? Is there anything appearing more than once? Actually, yes. 21 and 21. I listed these as 5 and 6, but of course I could have switched that. It makes no difference. So this does have a mode. And the mode is $21 million. Okay, let's do mid-range. So my smallest and my largest, 580 plus 4 divided by 2. That mid-range will be 292 million. That seems way off, doesn't it? But if you look at this and just glance at how few three-digit numbers we have on this list and how big those three-digit numbers get, those are some outliers. They're having a very strong influence on the mid-range, okay? And it's also likely to have a very strong influence on the mean. So we have our n value. We just need to add these up. If you add those up, then the sum of x is equal to 1,243. So the mean, 1243 divided by 13, which is approximately $95.6 million. Okay, now I keep mentioning these outliers and how strong an effect they can have on some of these measures. And this actually leads us nicely into the next section where we're going to talk about measurements of how far off those things are. Just how off are they? How far outside of the norm are they?